In this video, we'll talk about the trigonometric integrals. Okay, if the integrals have trig functions, then how do we find out? Okay, if there may be the product of two trig functions, or there may be exponent of a trig function, and so on. You know how to find what is the integral of sine x, cosine x, like that, but these integrals in this section 8.3 will have more complicated form of the trig functions. Okay, so you see that you will see something similar to this, or you will see secant and tangent, or cosecant and cotangent, and the product of two more than one trig functions. Okay, you see that if you see sine to the kx times cosine to the px dx, so on such functions, usually you don't need to use integration by parts. What you need to do here is you need to use substitution method first, and you may have to do use integration by parts later, but first we try to do this substitution method. Okay, when you do the substitution method, which trig ratio should be substituted by you? Then this is the rule. Okay, if k is even, if the sine to the kx, if k is even power but p is odd power, then we take that the function, the trig ratio with the even power as u, just sine x equals to u, not sine kx equals to u, just sine x equals to u. And then you will change that odd power as, because when you do sine x equals to u, you will get cosine of x dx will be du, right? That's what you get, right? So since this p is odd, then one of the cosine x will be cosine x dx. You will write du, and what is left is you will have cosine p minus 1, cosine to the p minus 1 x, right? And then that cosine, odd exponent of cosine, sorry, even exponent left, that even exponent of cosine will be changed into sine. Okay, that's what it is saying. But if other way, if k is odd, if this is odd but p is even, then set that ratio with the even exponent equals to u, and change sine into cosine. Okay, we'll see examples. And if both k and p are even, then what you need to do is you need to use the formula of sine square x equals to 1 minus cosine 2x over 2, or cosine square x equals to 1 plus cosine 2x over 2, and then you integrate. Okay guys, and if both are odd though, then you can set any of them as u, and then do the u substitution, and then if you need to do the integration by parts later after you change to u, then you can do that, but most of the time you don't need to, you get the answer right away. Okay, so let us see some examples. So I'm doing example number 4 from the book. Okay guys, so sine to the 7 2x and cosine to the 1, because there is no exponent, means 1, both are odd, right? So usually if both exponent are odd, you see that if both exponent are odd, then you can set up any of the exponent, any of the ratio as u, and then do the u substitution. But on that, if both are odd, then usually what makes easier is if you take the ratio with the higher exponent as u, trig function with the higher exponent as u, then that will make the problem easier. For example, what I'm going to do here is let sine 2x equals to u. See, I did not do sine 7th 2x. No, I'm just doing the ratio only, not the exponent. Sine 2x equals to u. Now find out the derivative. What do you get? What is the derivative of sine x? Cosine of 2x times 2, right? Dx will be du. So what is cosine of 2x times dx then? That will be basically 1/2 du, right? Now we take, let's suppose that is integral I. Okay, then I is equals to integrals, you have u to the 7 times du over 2. Look at that, how easy that becomes. You see that? So over du over 2. Let me erase that little tail there. So du over 2. How did I get that? Is I said that sine 2x equals to u, so it will be u to the 7, and we got that cosine 2x dx will be just du over 2. That's what I did. Now let me pull that 1/2 out, and then you got u to the 7 du. What is the integral of u to the 7? It is 1/2 u to the 8 over 8, right? Plus c. What is u though? 1 half, 1 over 16, not half, 1 over 16, because 2 times 8 is 16. U is sine 2x, so it will be sine 8 2x. That 8 is exponent, and then plus c. Sine to the 8 and then 2x plus c. That is the answer. Okay, guys. So that's how you do it. So let us do question number 6. So this is slightly different. Number 6 is, let's suppose that I equals, you want to find out the integral of sine cubed 3x. Integral of sine cube and then 3x is the angle dx. Okay, see, there is no product, there is only one, the ratio, that is just sine. Okay, in that case, if you know what is the formula for sine cube x, you can use that formula. If you don't know, that's fine. So what I want to do here is I want to make like this. This is like sine square 3x times sine and then 3x dx. You can write like that, right? Because sine cubed is sine squared times sine, right? And then what I want to do is, do you guys remember the formula? We have the formula like you have sine squared x plus cosine squared x equals to 1. So what will be sine squared then? Sine squared will be 1 minus cosine squared. That's what I want to use, so that I'll have sine and cosine. Okay, so it will be 1 minus cosine square 3x and then times sine 3x dx. You see that there is a product of cosine and sine, and cosine has the even exponent, right? Cosine has the even exponent, so that should be u. Okay, so let us continue from there. Set cosine of 3x, not with the exponent, just the base function, right, equals to, you find out the derivative, negative sine 3x times 3, right, equals dx equals to du. So what do you get then? So it will be sine 3x and then dx will be equals to negative 1/3 du. Does that make sense? Now therefore the integral I, hence the integral I is equals to, you can write 1 minus u square. You see that? And that sine 3x dx will be negative 1/3 du. So let me pull that negative 1/3 because that's the times. Let me pull that negative 1/3 out. What do you get? 1 minus u square times du. Okay, guys. So negative 1/3. What is the integral of 1? It is u minus integral of u square is u cubed over 3, right? And then plus c. Let me plug in back to this cosine. So negative 1/3. So that will be negative 1/3. U is cosine 3x minus u cubed is cosine to the cubed 3x over 3 and then plus c. That is the final answer. Okay, guys. So the next problem I want to do is example number 7 from your book. Okay, example number 7 or the question number 7. So it is sine cubed x cosine squared x dx. So it will be like sine cubed x times cosine of squared x dx. You know what? If you don't remember the rule that I just mentioned here on the very left column, okay, what it says is, if there is an even and odd, then the ratio with the even exponent should be u. Okay, in the product of sine and cosine. If there are both even, then you need to change that to the multiple angle formula. Okay, that formula is given in the front, I think very first page or the second page of your book. Okay, and if both are odd, then you can assume that any of them as u, but usually the higher exponent, the ratio of the higher exponent should be considered as u. Okay, guys. Now, but what happens if the one of the exponent is not even, if it is like fraction, then, and the other is non-fraction, that fraction one should be u. We'll discuss so many such type of problem. Okay, guys. All right, so how do I do the this problem here, sine has odd exponent and cosine has even exponent. So obviously cosine should be, you see that cosine has even exponent, that has p is even, then set that even exponent equals to u. So cosine of x equals to u, set. So if you set cosine equals to u, then negative sine x dx will be du. You see that? So sine x times dx equals to negative du. Okay, now how do you write that integral? Let's denote that by I. Let's say then I is equals to, you can write sine cube as sine square x times cosine square x times, you can write sine x dx. See that? Now from this formula, what you can write for sine square is 1 minus cosine square. So I want to write everything in terms of cosine square so that I can replace by u. That's my trick here. Okay, so it will be 1 minus cosine square x, right? And then cosine square x, right? And then sine x dx. You may be curious, why did I move one of the sine to the last, to the end? Is because I can write sine x times dx equals to negative du. That is the reason. Okay, so let me write down, or let me finish that problem here. That can be written as I is equals to, you can add 1 minus u square, and there is outside u square, that because cosine square x times negative du. So let me pull that negative sign to the front. Okay, negative integral, and move that, distribute that u square minus u to the 4, and then du. Okay, now find out the integral. Negative, what is the integral of u square? That is u cubed over 3, right? Minus, what is the integral of u to the 4? It will be u to the 5 over 5, right? That's the power rule. And then plus c. So how would that look like? Negative u is cosine, so it is cosine of qx over 3 minus cosine of 5th x over 5 plus c. So you can write this as the final answer. Okay guys, so let us do a couple more problems here. So let us do question number 10 from the book. Question number 10 is, there is sine to the 5th, cosine 5th t. So integral cosine 5th t divide by, you get sine t under the root sine t, and then there is dt. You see that there is no product though, there is like ratio. Okay, so in the ratio, usually what you do is, you see that there is a sine has the square root, so that square root means 1/2 exponent, right? That is basically exponent 1/2. So in that case, usually what you do is, if there is a square root or fractional exponent, the ratio with that exponent, fractional exponent or a square root, should be u. Okay, that's what we do it. So let us do that. Let sine t equals to u. Okay, what is the derivative of that? Cosine of t dt will be du. You see, now the integral I can be written as I equals to, you can write cosine of, you can write square x times cosine of square x times, oh not x, t, right? So let me write down t, cosine square t, and then you will see why did I do cosine square t like that. Okay, t, and then times cosine of t dt over root under sine t. You see that? So the reason why I need cosine t dt is to replace by du, and the reason why I need cosine square t is because we know that sine square t plus cosine square t equals to 1. So cosine square will be 1 minus sine square t, but sine t is u, so you can write cosine square t as 1 minus sine square t, that will be 1 minus u square. So you can replace that cosine square t as 1 minus u square. But if you have cosine, if you write like cosine 4th t is cosine 50 as cosine 4th t times cosine t, then you don't know the direct formula for what is cosine 4th t. We know the cosine square t is 1 minus sine square t, but cosine 4th t, you don't have the direct formula. That's the reason why I did like product of three things: cosine square, and cosine t. Okay guys, So that is written as, you can write again 1 minus u square, because this is 1 minus sine square and sine is u, that's why. Similarly 1 minus u square and times du over root under u. You see that? Let me simplify that parenthesis. Let me FOIL that. 1 minus u square is u square minus u square plus u to the fourth divided by root under u and then du. Does that make sense? So if you simplify this, you will get 1 minus 2u square plus u to the fourth over, what I'm going to do is, I want to write u to the 1/2 and then du. Just trying to simplify, okay? Just the simplification. Now you know that we don't have a quotient rule of the integral. So what I want to do is, I want to try to split that. So what I do is, I want to write 1 over u to the 1/2, 2u square over u to the 1/2, and u to the fourth over u to the 1/2. That will look like this: 1 over u to the 1/2 minus 2u square over u to the 1/2 plus u to the fourth over u to the 1/2 and then du. You can cancel those things there, right? Do you see? What is 1 over u to the 1/2? You can write u to the negative 1/2, right? And then minus 2u to the, if you move this to the top, it will look like this. It will look like 2u square times u to the negative 1/2, right? You can combine that, u to the 2 minus 1/2. So it will be like u to the 2 minus 1/2. What is that? It is u to the 3/2, right? So that's what you can write. Let me write down that 2u to the 3/2 plus, similarly, how do you do that? It will be like, it will look like u to the fourth times u to the negative 1/2, right? So there will be u to the 4 minus 1/2. How does that look like? U to the 7/2, okay? So that's what I'm going to write here, u to the 7/2, and then there is du. Let us use the formula, that power rule, right? So it will be u to the negative 1/2 plus 1 is positive 1/2 over 1/2 minus 2 times u to the 3/2 plus 1, okay? That will be 5/2 over 3/2 plus 1 is 5/2 plus u to the 7/2 plus 1 is 9/2 over 9/2 plus c, okay? So how do you write that? This is like 2 will go to the top, right? It will like 2 root u, because u to the 1/2 is root u. Now this will be minus 2 times, it will be like 2/5, right? If you write in the top, it will be 2/5. So it will be 4/5 and then u to the 5/2 plus it will be 2/9 u to the 9/2 plus c. Let us plug in the value of u. That will be 2 under the root sine t minus 4 over 5 sine to the 5/2 t, and then plus 2 over 9 and then sine 9/2 t plus c. That's what the final answer of this. Okay, guys, so that was question number 10. All right, so how would you do question number 14 then? Let me do question number 14 next. Okay, so question number 14, it says integral of x square and then sine square x dx. Okay, so here u substitution will not work. Why it does not work? The reason is, you have, like, if you set sine x equals to u, we need cosine x dx as du, so we don't have cosine x dx there. Okay, so what you need to do is, sine square x should be changed to by using the multiple angle formula. So what is that multiple angle formula thing is? You know that sine square x equals to 1 minus cosine of 2x over 2. That is the formula for that. Okay, let me use that formula. This is equals to integral x square and then 1 minus cosine of 2x over 2 and then dx. Okay, so let me write down 1/2 outside, and then I don't need bracket there. I can write the integral there, and then distribute that x square times 1 minus x squared cosine of 2x and then dx. That's what you get. Okay, now on this one you can use, for the second one you can write like, what is the first one? 1/2 x cubed over 3. That's the integral of that one. And then minus 1/2 integral x squared times cosine of 2x dx. So I need to use integration by parts here. Why I cannot use integration by parts? Because I don't know what is the integral of sine square x. That is the reason. Okay, so but I know what is the integral of cosine 2x. Cosine 2x will have sine 2x over 2. That's the integral. Okay, but before we do the integral, we need to first make sure that which should be u function and which should be the v function there. Okay, so you see that? Do you remember that ILATE thing for the u? So this is for u, right? So if there is inverse function, that should be u. If there is log function, that should be u. If there is an algebraic or polynomial function, that should be u. So that should be u. That should be v. So what is the integral formula? The formula is u times v dx is equals to u integral of v dx, and then minus integral of the derivative of u, integral of v dx, and then there is a dx outside. Okay, so we will keep the first term as it is. The first term will be the same, 1/2 and then x cubed over 3 minus, and then there is 1/2. I'm using that formula. So u integral of v, that will be x squared times integral of cosine 2x is sine 2x over 2. Okay, and then minus integral of u prime. That will be what will be u prime is 2x times, that will be sine 2x over 2 and then dx, right? What do you get? You get 1/6 x cubed minus 1/4 x squared times sine 2x, right? And then minus minus plus, because this negative times negative is plus, that 2 and 2 will cancel out, so you'll get 1/2, right? Because 1/2, and then integral of x times sine 2x dx. Again you need to do u and v, so this will be u, this will be v. Okay, so if you do that, what you get is 1/6 x cubed minus 1/4 x squared times sine 2x plus 1/2 times, again, so u integral of v is x and then times negative cosine 2x over 2, because the integral of sine 2x is negative cosine 2x over 2, and then minus, so it is derivative of u, integral derivative of u is 1 times the integral of sine 2x is negative cosine of 2x over 2 dx. Okay guys, there is also closing the parenthesis. Now that will be 1/6 x cubed minus 1/4 x squared times sine 2x minus 1/4 x times cosine of 2x, because I'm just distributing this 1/2. Okay, and then minus is plus, so plus 1/4 integral of cosine 2x dx. If you find that integral, your final answer look like 1/6 and then x cubed minus 1/4 x squared sine 2x minus 1/4 x cosine of 2x plus, you get 1/4 is there. What is the integral of cosine 2x? It is sine 2x over 2. So 1/2, you will get 1/2 there, and so that will be 1/8, right? And then sine 2x plus c. That's it. But do you remember the table method? Table method also will work for this problem, because what you can do is you can write just this one, but for the second integral you can write u and then v x squared, because when you find the derivative it will end up with 0, right? Cosine of 2x. You find the integral of v, derivative of u, 2x to 0, integral sine 2x over 2 and then negative cosine 2x over 4 and then negative sine 2x over 8. Okay, 1 2 3 4 1 2 3 4. Okay, we are good. So what I'm going to do is I'm writing these diagonal lines. The first one is positive, second is negative, and then third one is positive. So how would that second integral look like? Then the answer is equals to, you can do it directly like that, right? You can write 1 over 6 x cubed, right? And then plus, you see that 1/2, and then x squared times, so there is 1/2 already. Okay, there is 1/2 already, so you can write like that, and then x squared times sine 2x over 2, that will be sine 2x over 2, right? And the next one is negative. This is negative multiplication, but there is a negative sign, so you will write plus 2x times cosine 2x over 4 will give you x cosine 2x over 2. And the next one is, it is minus, right? This one is minus, but that will make, by the way, this is negative sign here, right? This is negative sign here. This is negative sign. So the first one is plus, second one is also plus, and third one is minus 2 times sine 2x over 8, but 2 and 8 will make it sine 2x over 4. Okay, if you distribute that 1/2, negative 1/2, you will get exactly the same answer. Okay, so as I mentioned in the last video, that sometimes you can use table method. When can you use table method? If the u function is a polynomial function whose derivative will turn end with 0 ultimately. Okay, and if the other function is easy to integrate, then you can use the table method as well. Okay guys, so in the next video you will see more example of the integrals involving trig functions. All right.